As you can see, our today's topic is prism. Okay, so basically all the phenomenon of prism is related to the refraction of light, and that is why prism is in this chapter. So let me draw a figure. This figure is very much important and already you have done it in class 8 also. Okay, but just look at this figure. Okay, just draw a prism as we usually do. Okay, and let's say this is the incident ray. This is the incident ray, and after refraction it is passing through the prism, and let's say this is coming out. Okay, now draw normal. So let's say this is a normal. I am drawing with a dotted line, and this is another normal. I am drawing with the dotted line. Okay, so basically this is the prism A, B and C. Okay, and this AB and AC surface are known as the refracting surface of prism. What I am saying, this AB and AC surface, so AB and AC is known as the refracting surface. Refracting surface of prism. These are the refracting surface of prism. Okay, and I am giving the name of this ray of light. Let's say this is P, this is Q, this is R, and this is S. So I am not writing, but you can easily see that PQ is the incident ray on the first surface of the prism, and this is the angle of incident. I am giving it as I1, and this is the angle of refraction on the second surface. Sorry, first surface. I am denoting it as R1. Okay, this is R1. Next, this is R2. This is angle of refraction on second surface, and this is I2. This is called angle of emergence. Okay, I am giving a name. This is as O. This is O. So this is the refracting surface, and BC is called the base of the prism. This is the base of the prism. As you can see, angle AQO equal to 90 degree. I am writing it here, angle AQO, that is equal to 90 degree. Why this is 90 degree? Because this is the perpendicular drawn on surface AB. Okay, and angle ARO, that is also 90 degree. So I am writing angle ARO, that is equal to 90 degree. Last day we have missed one thing, that is deviation. What is deviation actually? So let me tell you what is deviation. Already I have told you many times in previous classes. Let's say this is a medium, separation of medium. Let's say this is a rarer medium, and this is a denser medium. This is a denser medium, and light ray is, this is the normal, and light ray is coming from here. Light ray is coming from here and incident here. So as it is coming from rarer to denser medium, so it will change its path. It will come closer to the normal. Okay, so what is happening basically here? What is happening? Look very carefully. The light is changing its path. So light should go along this direction. Light should go along this direction. No, but light is not going along that direction. Rather, light is changing its path. That means the light is deviating from its destiny. Light is deviating from its path. So that is why this angle is known as angle of deviation. This angle is known as angle of deviation. That means to along which direction it should go, along which direction it is going. So this is the difference between the difference between these two angles is known as the angle of deviation. So look at this also. If the prism is not here, along which direction light should go? Light should go along this direction, right? But as the prism is here, light is going along this direction. So I am producing this line too. So as I told, the angle between where the light should go and where the light is going, the angle between these two paths is known as angle of deviation. Here the same thing. Here the light should go and the light is going along this direction. The light is going along this direction. So that is why this is angle of deviation and I'm denoting it as delta. Okay, I'm denoting it as delta. Okay, I'm giving a name here. Let's say this is M and this is N. I'm just giving a name. And this delta is known as the angle of deviation for prism. This is known as the angle of deviation. So the doubt of last day has been cleared that what is delta. You have few of you have requested me that to explain this thing. Okay, so this angle delta is the angle of deviation. Now we shall calculate the value of this angle of deviation. Before that, let me tell you one thing. This angle of prism is very much important, this angle, and this angle is known as the angle of prism or the refractive angle. Angle of prism or refractive angle, and that is denoted by A. Sometimes with angle A or sometimes with A. Okay, so this is the angle of prism. Angle of prism or refractive angle of prism. Okay, now we shall derive the value of delta from here. Okay, look very carefully. Delta, that is angle of deviation. Look at this small triangle. Very carefully, look at this small triangle. This delta is the external angle of this triangle, right? This delta is the external angle of this triangle. So we can say that external angle that is equal to the sum of opposite two triangle. That is a theorem of your class. So delta equal to, we can write this angle, that's mean NQR plus this angle NRQ. So I am writing delta equal to NQR plus angle NRQ plus angle NRQ. Is it okay? Now look at this angle NQR, that is equal to, we can write I1 minus R1. Why? Because look at this I1 and this is the opposite angle of R1 I1. So this whole angle is R1, that's mean angle NQO, that is equal to I1 because they are opposite angle. So this small angle is basically the whole angle minus this angle. So I1 minus R1. So I am writing it as I1 minus R1. If you do not understand, just rewind the video and watch again. Okay. Plus, now look at this NRQ. Again this is same. So angle R2 and the whole angle NRO is opposite angle. So the whole angle is I2. So what about this small angle? The whole angle minus this one. The whole angle is I2 minus this 2 minus this R2. So we can write is I2 minus R2. Again, if you do not understand, rewind the video and watch again. Okay. So from here what we can write? I1 plus I2, and if we take minus as common, R1 plus R2. Is it clear? So delta equal to I1 plus I2 minus R1 plus R2. Okay, now look at this thing very carefully. Another geometry we shall do here. Look at this quadrilateral AQOR. Okay, look at this quadrilateral AQOR. That's mean from quadrilateral AQOR, what we'll get? We'll get angle A plus angle AQO plus angle QOR plus angle ARO, that is equal to 360 degree. Nothing but sum of all angles. So this is angle A plus angle AQO plus angle QOR plus angle ARO. So all these four angle, that is equal to 360 degree. But what we have done previously, angle AQO, angle ARO, both are 90 degree. So this is 90 degree and this is 90 degree. So what we can write? Angle A plus angle QOR, that is equal to 360 degree this, if this come this side, that will be minus 90 degree, as it is 90 degree, and this is also 90 degree, minus 90 degree. So this is 180 degree. Is it okay? Okay, so angle A, that is equal to, we can write 180 degree minus angle QOR. So what is up to here? Angle A equal to 180 degree minus angle QOR. Now look at this triangle. Look at this triangle, and triangle QRO. Okay, I am doing it here. Triangle QRO. Very carefully. So sum of these three angles are 180 degree. Sum of this triangle means R1 plus R2 plus QOR. So I am writing here R1 plus R2 plus QOR. By the way, draw this figure first. Okay, then try this. That will help you. So all this three angle is 180 degree, and of course note it down in your copy. So what we can write? R1 plus R2, that is equal to 180 degree minus QOR, right? So 180 degree minus QOR. Same, angle A equal to 180 minus QOR. So R1 minus R2 equal to 180 degree minus QOR. So can we write this? R1 plus R2 equal to, from here, angle A. So is it clear? Or simply A? So let's put this R1 plus R2 here. Okay, so delta equal to, we can write I1 plus I2 minus A. This is the formula, and this delta is known as the angle of deviation for the prism. And this formula is very much important for numericals and for your exam also. Okay, just do this proof, pause your image and note it down. Do this proof. Okay, next what we shall discuss about? We shall discuss about the factors. Which factors? The factors which affecting the angle of deviation. The factors which affecting the angle of deviation. So first thing I shall talk about, that is angle of incident. That is angle of incident. First thing is angle of incident. So how angle of incident influence this thing? This is very much important. The angle of incident increases, the delta increases. Okay, from here you can see, if I1 increases, delta increases. Okay, the next thing which affect more, that is A, that is angle of prism. So what we got? If angle of incident increases, delta also increases. Okay, next A. So for a fixed angle of incident angle, if A increases, delta decreases. Let us just look at this. This is as negative. So if the value of A increases, that means it will subtract more from this value. So delta will decrease. Is it okay? Delta will decrease. But sometimes we got some different different consequence from there. Okay, and that is actually a different issue, better to say. For a thin prism, the value is sometimes like that. Okay, before that, just look at this for a normal prism. Okay, I shall explain that later. Okay, next 3, that is the refractive index of the material of the prism. Refractive index of the material of the prism. It has been seen that if refractive index increases, delta also increases. If refractive index increases, delta also increases. Okay, so more the refractive index, more the deviation, as we can see from here. More the refractive index, more the deviation. So next is lambda. So if lambda decreases, delta increases. So just consider the case of dispersion for white light. We know, so this is red and this is violet. So violet is deviating more, and violet has smallest wavelength in visible light. So smallest wavelength, deviation is more. Okay, and let's talk about this thing now. One thing you will know that for a thin prism, of course I am talking about a thin prism. For thin prism, the formula is something like that, that delta, that is equal to mu minus 1 into a. This formula you will get in class 12, but here the formula only that is given, delta equal to mu minus 1 into a. That's mean if a increases, delta also increases. That's mean if a increases, delta also increases, and we shall consider that if a increases, delta will also increases for thin prism. Okay, so these are the four factors, and these four factors are very much important. Also this question is also very much important from here. Okay, now let's talk about one thing, about this thing. Okay, we shall draw a graph, and the graph is very much important again for exam. What is this graph about? This graph, let's say I am drawing the graph here. That's mean delta along this direction and angle of incident along this direction. So if we plot delta with the angle of incident, we will find a graph like this. That's mean first, when the I increases, delta decreases, and after a certain value, and at a certain value of I, delta becomes minimum. And then also with increasing with I, delta will increase again. So this minimum value of delta is known as the minimum deviation, and it is denoted by delta m. This is known as minimum deviation, and this is denoted by delta m. So what is the situation of this minimum deviation? That's mean when we can find this minimum deviation. Basically it can be shown, but this is not in your syllabus. That is when I1 equal to I2, then delta will be minimum. When I1 equal to I2, then delta will be minimum. Just now remember this, take it in your mind, no proof is needed for now. So when I1 equal to I2, then delta is minimum. You will do this proof in class 12, or you can see the video of class 12 available in this channel from class 12 playlist. Okay, so when I1 equal to I2, then this is minimum. Okay, so when I1 equal to I2, then what will be this formula? This formula will be delta equal to I1 plus I2. Now both are same, and I am taking it as I, so I plus I minus a. This is delta mean. So delta mean equal to, we can write 2I minus a. This is a formula, and that is very much important. Now you few things given in your book, that's how using this figure you can solve various type of problems. Now I shall give you a few steps, listen very carefully. So there can be several types of problem. One is angle I1 is given, mu, that's mean refractive index of this prism is given, you are asked to find I2. Oh, another thing, this formula is also very much important. So R1 plus R2 equal to A, that is also a very important formula. So formula number 1, 2, 3, so these formulas are important. Okay, what I am saying now, the problem is like I1 is given, you are asked to find I2. Very simple. If I1 is given, apply the Snell's law, as mu is given, apply the Snell's law and find R2. R2 given, suppose A is given, then by using this formula, sorry, R1 you just calculated, A is given, so by using this formula you can find R2 equal to A minus R1. So just calculate R1 and again apply Snell's law to calculate this. Lot of problems are given as example in your book, so solve this. If you face problem, you can tell me, and again we shall solve this type of numerical problem in another classes. Okay, whatever all this video that is the class that we have done previously are available in playlist of class 10 in this YouTube channel, and please subscribe this channel, that will motivate me to make more videos. Okay, and out of class I shall upload a few more videos for you only, okay, to just handle this type of topics. the more what to say, whatever. Just this is the end of the class, and please press the subscribe button, whatever. Thank you. And also I am sharing the link of this playlist also.